One of derivative carboxylic acid is amine. Okay, first we look at the preparation, how to prepare of the amide and reaction of amide. Okay, this one for the preparation of amide. First, from carboxylic acid. Okay, from carboxylic acid, okay, react with the ammonium, this one carboxylic acid react with this one to form the ammonium salt. Okay, and then from this one salt by heating to form amide and water. Okay, so this from the carboxylic acid convert to ammonium salt first, and this ammonium salt we heat this ammonium salt to form amide. Okay, from acid chloride, this one is acid chloride. Okay, react with ammonia to form amide. React with 2RNH2 to form primary amide and secondary amide. If you react acid chloride with the secondary amine. So this is an example. So next is from acid anhydride. This is acid anhydride react. Okay, acid anhydride react with this ammonia through ammonolysis, acid anhydride, to form to form the amide, secondary amide, primary amide and secondary amide. But make sure in ammonolysis we're using a 2 mole of reagent. So from ester react with ammonia, primary and secondary amide to form amide and alcohol. Okay, this one primary amide because there are 2 proton on N, secondary amide because there are 1 alkyl group on N, and tertiary amide because there are 2 of alkyl attached on N. Okay, next is reaction of amide. So there are about 5 reaction. First, hydrolysis. Okay, hydrolysis is mean amides undergo hydrolysis, react with water to form carboxylic acid. Okay, but it's divided into 2 conditions. First, acidic. If you use acidic, so you can get the carboxylic acid with ammonium ion. But in basic condition, we're using the OH minus, so we can get the carboxylic salt with ammonia. Okay, so here is amine react with the water using acid and base. So acid we can form carboxylic acid. Okay, if you are using a basic condition, you can get the carboxylic ion. So this one is mechanism in acidic hydrolysis. Okay, amide undergo acid-catalyzed. We call acid-catalyzed hydrolysis to give the carboxylic acid. Okay, first step. Okay, if the nucleophilic substitution are acid-catalyzed, so first step must be protonation. Okay, protonate carbonyl. We want to protonate carbonyl because we want to activate the C double bond O. So that next step easy to nucleophile attack on C double bond O. Okay, so you form first this one. Okay, C double bond O positive H. After that, step 2, water attack on carbonyl. So this lone pair is very strong. Nucleophile can attack this strong electrophilic. Okay, so the reaction called as the pi bond is cleave. Okay, it becomes COH. Okay, but in this structure there are lone pair, so lone pair abstract this proton. Okay, to form NH3, this one positive, so this one become OH. So step 3, we want to eliminate. Eliminate means that we want to form double bond here between C and O. Regenerate to become C double bond O, and ammonia is released. and it's released. So it becomes C double bond O OH. OH in here, this one becomes C double bond O. So this hydrogen abstract by water. Okay, so actually the mechanism this same like previously, same in the chapter aldehyde and ketone 2 about the nucleophilic substitution, because this one mechanism for acid catalyst, because of acid is very weak. Okay, because of this compound is very weak electrophilic, so need protonation. Okay, protonate, so become more electrophilic. Once become more electrophilic, so nucleophilic can attack on this carbon, okay, to form this one. And then next step is to eliminate to form this C double bond O. So this one hydrogen will abstract by water, and then ammonia will leave from the structure, this C. Okay, next is reaction with nitrous acid. Okay, amide with nitrous acid to form carboxylic acid and nitrogen. So next is reduction to amine. Okay, primary amide, strong reducing agent to become primary amine or primary amine. Okay, secondary amide become secondary amine. Tertiary amide become tertiary amine. Okay, if using the strongest of reducing agent. So this one is mechanism of reduction. So amide. Okay, so this one lone pair attack this carbon. So this one pi bond cleave to form O minus. Okay, to form the iminium ion, and lastly to form amine or amine. Next is formation of nitrile. Okay, dehydration of amide. Okay, this amide, okay, by using dehydrated by heating and also P2O5, you can get the nitrile RCN, side product water, and H3PO4. Okay, for the Hoffman degradation, please star for this one. Hoffman degradation, we want heating this amide with mixture of bromine and KOH or sodium hydroxide. All this is a very strong base. Okay, so amide will change to amine. Okay, it's used to shorten the chain by one carbon. Okay, shorten one carbon. So reaction of bromide with sodium hydroxide form sodium hypobromite. Okay, primary amide chain into intermediate isocyanate. Okay, and lastly to form primary amine. Okay, there are different situations from this. This one is using KOH. Okay, this one is using NaOH. If using NaOH, you form intermediate isocyanate, and then undergoes to form primary amine. So here is exercise, and you can try to do these exercises, can make you better in understanding about this chapter. Thank you.